Have you ever heard about converging plates forming mountains or diverging plates creating oceans? Well, it's a super slow process that can take millions of years. To understand the movement of plates, all kinds of techniques have been developed, besides just fieldwork. There is geodynamic modeling software to visualize how plates move. There are numerical models built on physical theorems to simulate how plates break apart or come together, but that's all in theory. We can also go into the lab and find out how this works with real materials. So let's go back in time when there was no Atlantic Ocean and see if we can find out more. In the lab, I make a series of experiments using silicon putty and sand that will float on a heavy liquid. It takes like a day to make such a model, so I hope you're ready to prepare with me South Atlantic's next star model. I start by putting the first silicon putty layer in the model box on top of a heavy liquid. This layer represents the ductile part of the strong upper mantle. I dry the surface to avoid heavy liquid in the model. Then I fix the borders and make sure it touches all sides of the box. I let it rest so it will be as homogeneous as possible. Next, I prepare a second silicon layer for the right side of the box and a quartz layer for the left side of the box. The difference in materials ensures different rheological strength. The different colors of the quartz sand I use to enhance the contrast in deformation structures when cutting cross-sections later on. A second layer of silicon putty, with different properties than the first one, represents the ductile lower crust. It is lighter, so less dense, but more viscous, so with more resistance to flow. The last step before I can run the model is the brittle upper crust, which is represented by feldspar sand. Again, I use different colors to enhance the contrast of deformation structures later on. So the model rested during the night and it looks pretty relaxed now. In a couple of minutes, a mobile wall will start moving away from the model, creating extension. I'm pretty excited. I hope that South Atlantic's next top model will develop. I run the model for 3 hours and that gave me an extension of 3 centimeters, and as you can see here, it only developed in the weak part of the model. Model 2.1. The judges weren't sure if it was something that could be healed, but you did it. You are South Atlantic's next top model.